Hello, and this is the Carleton University Mathematics Tutorial series, and this series is devoted to differential and integral calculus. My name is Brian Mortimer. I am a professor of mathematics in the School of Mathematics and Statistics at Carleton University in Ottawa, Canada. This particular series of videos is provided as a resource that students can use to complement their studies for any calculus course they happen to be working on, and it is not intended as a full credit course on its own. This particular introductory video will begin by looking at the various different ways that calculus can be formulated and the ways that we change calculus to make it useful for different purposes. We'll pick from this list the one that we're going to work on in this video series. The next topic is the pedagogical approach that I like to use when I'm teaching this subject, and we will be following in this particular series of discussions. We turn after that to the student, to you, and I want to talk about what I've learned during the 30 years that I've spent teaching calculus to students. And I want to get you thinking about what is your optimal way of studying this subject, because every student has a different way that they actually learn the mathematics that's involved in what we're talking about. And then the final topic for this introductory video is to look at the way technology has developed over the last few decades, so that now we have very sophisticated technology that we can download to our smartphones that can look after the technical parts of calculus, and how that is changing the way that students study calculus, and also the way that mathematicians do their applications of calculus. Now, there are actually a number of different ways that you can study calculus. The first that I'm going to talk about is calculus as a toolbox. We can view calculus as a set of tools that mathematicians use to construct mathematical models. And this is really the way calculus began, with a long time ago, with people who wanted to build mathematical models of important phenomena around them, and they used calculus to do that. Another distinction we can make is that calculus could be considered to be single variable or multiple variable. We can use functions with one variable or functions with more than one variable. A simple example of a situation where you need at least two variables is suppose you are trying to fit a straight line to a set of data points. The line you're looking for has both a slope and an intercept. And so when you go into the optimization problem, there are two variables you're looking for. There are many models that have many more variables than that, and we need calculus tools that will work in those situations too. Now, another important way of looking at calculus is as a rigorous subject. And what this means is that after about 250 years of use, calculus was finally given a completely rigorous logical foundation through the precise definition of the concept of limit. And that form of calculus then is one which we teach to students interested in mathematics as their primary subject. And in this series of videos, I will be talking about this rigorous side of calculus. I don't want to leave the proofs as black boxes, and so we're going to end up with proofs that are more gray boxes than black boxes. And finally, when calculus finally had its formal foundation, it became very abstract, because this allowed mathematicians to go on and to study calculus from the point of view of what sorts of models are even possible, what properties does a whole family of models actually have, calculus is then renamed analysis, and it takes off and has a whole new life that developed all through the 20th century. In this particular video series, I'm going to be treating calculus as a toolbox which is used to construct mathematical models. And we will talk about models all the time through the series. Next, let's say a word or two about pedagogy. When we're studying calculus, there are actually going to be 4 aspects of each topic which I am going to try to emphasize. When we come to a tool or a topic within calculus, we want to know what it does, what it means, what the geometry actually looks like, and then we want to know how that tool is used to solve problems. These 4 different pedagogical aspects of each question are ones which you should be thinking about as well, and you should be able to write a short paragraph about each of the topics that we consider, and that includes 4 sentences that address these 4 different issues. What it does, what it means, what it looks like, what it's used for. I've just made a very short list of the kinds of models I'm talking about. Climate models are the most complex models that we have at the moment, and they are of vital importance as we try to work out what is going to happen as our climate changes and what will happen if we make policy decisions in this area. Weather models are also very important and are quite different and are even harder than climate models to construct. We can look at other questions like why there is a rainbow, and that involves some mathematical modeling with inverse trig functions. Spread of disease is important. The impact of monetary policy is one which has a lot of interest. So we're going to be looking at lots of different models, and every tool will be expressed in part as to what problems it lets us solve. Okay, let's talk about you for a little while. Every student who studies calculus does it in their own way. And you will have your own optimal way of learning. Perhaps you learn best by listening, by reading a textbook or reading other materials. Maybe you learn best by watching people do mathematics, or perhaps by doing practice problems yourselves. Maybe you learn best by asking questions, by taking your own notes. Do you learn best from people, from mistakes, from the internet, by moving in a spiral? What does that mean? That means that most people do learn in a spiral in the sense that when you move ahead, you'll move ahead until there's something you don't understand. Then you move back to where you were studying that, but with a new perspective and motivation. You learn what you require, and then you move forward again, but with an improved understanding of what happens, and move past the roadblock on to the next subject. So most learning can be described as a spiral, and if you're conscious of that in your own learning, it may help you to learn better. Do you learn best at the last minute? Very, very few people actually do learn best at the last minute, but it might be that you are that person. And if so, you should be aware of it. So find the resources that are available that support whatever style that you have. Remember that there is really no substitute for sustained, focused thinking. You can't develop a strategy really that will allow you to postpone all of your thinking and practice in studying mathematics. Practice is always the key to mastering any technique. Try to see each problem as only a special case of a general situation. The ability to move from looking at a special case to a general problem is a key one in intellectual growth, And you should be conscious of that as you study mathematics and try to get yourself to think in those terms. Always you should be looking for the meaning and significance as well as technical correctness. The final topic is technology. We have seen a tremendous development of the technology that supports calculus in the last 2 decades. You can now download to your smartphone software which can do all of the technical problems in any undergraduate mathematics course. The software is very modestly priced, and you should actually be looking into this and learning how to use this software, because in the future it will be this software that does all of this technical part of calculus. In this video series, in fact, most of the graphics are produced on my iPhone. So you should learn how to use this technology and go ahead and use it. But be aware that the technology replaces the purely technical part of a calculus course. It gives you the facility to do the technical skills part. What it can never do is replace the understanding that you develop about what you're doing. It can't provide meaning or understanding. It can only provide technical correctness. So I think that technology is a very important development for the study of calculus, and we all have to learn how to put it in exactly the right place. And it allows us, in fact, to spend more of our time thinking about what this all means. Let me wrap up with a summary of what I've tried to convey in this tutorial. First, the series is going to be about calculus as a tool for building models. Secondly, every topic will be considered from 4 perspectives: what it does, what it means, what it looks like, and what it's used for. Students must develop their own optimal strategy for learning. That is basic homework for you. And technology can do all the calculations but provide none of the meanings.